A Viking navigator could find the sun on a completely overcast day. They used a crystal, a sunstone. This piece of rock may have guided their longships to the shores of America. Centuries before other European explorers arrived, it's a lost technology, part ancient legend, part modern physics. They could see the invisible, and this secret faded from history. We're still trying to solve their mysteries. Leif Erikson sailed from Greenland. He was heading toward lands unknown. The sagas say that. They describe a coastline of flat stone slabs. They called it Helluland. Further south, they found forests, thick forests. They named that place Markland, the land of wood, and then they reached a warmer shore. Wild grapes grew there. They called it Vineland. These aren't just stories, there's proof. At Elance Oaks Meadows in Newfoundland, archaeology confirms it. Vikings built a settlement there. That was over 400 years before Columbus, but the ancient texts, they're full of adventure, but they hold back a secret. A crucial one, they never explain how. How did they do it? A longship, it's open to the fury of the ocean. They navigated over 1,000 miles. The most dangerous seas on Earth, the North Atlantic, it's a place of perpetual cloud, sudden fog, storms that can blot out the world for days, the magnetic compass. That tool guided later explorers. It likely hadn't reached the Norse world yet, so they were sailing blind. Yet they weren't blind at all. They saw something. Something we cannot see. That's the historical puzzle. It turns a legendary voyage into a mystery, a profound technological mystery. We know they reached America. The burning question is this: what invisible signposts did they follow to get there? It started with their ship, the Viking longship. This wasn't just a boat, it was something they'd shaped to the water. Built with overlapping planks, all riveted together, that made the hull flexible, strong. It could ride over the waves, and it was shallow, so it could go right up a river or onto a beach. The bow and the stern were the same, so you could reverse direction without turning around. This was a vessel for finding new places, for the open sea and for unknown rivers. But a ship like that is only part of it. It needs someone to guide it. That was the navigator, almost always a man. He carried a map in his mind, built over centuries. He watched everything. The way seabirds flew could lead you to land you couldn't see yet. Whale migrations were like roads across the deep water. He learned to read the ocean's swells, how their rhythm changed near a coastline. This was knowledge passed down, sailors memorizing the sea's personality. For clear days they had tools. One was the bearing dial, a wooden disc with notches. You'd track the shadow from a center pin. It was a simple sun compass, a way to keep your course when you could see the horizon. But then there were the other days. When the sky was just gray, when it all blended together, sea and sky, and every direction looked the same. That was the real danger. The ship could take a storm. His knowledge could read the waves, but without a fixed point in the sky, all that skill, you could just sail in circles. You could be lost. So Viking navigation, it was a system. Layers of methods. The ship was one part. Reading natural signs was another. The bearing dial was for good weather. It was a network, so if one thing failed, maybe another would work. And within that system, the idea of a tool that could see the sun through the clouds, it doesn't seem strange. It seems like the next step, the logical one. The Sunstone, it wasn't some fantasy. It could have been the peak of what they knew, the answer to their biggest problem. So what was it? This crystal that could find the sun behind a blank sky. The answer is in one line of text. A short mention in a 13th century saga, the Tale of Hrothulf. It describes the sky as overcast, completely gray. King Olaf, who is known for his wisdom, wants to know where the sun is. He asks a man named Sigurd to check, and Sigurd pulls out this object, a solar stein. A sunstone, he holds it up, looks through it, and then he can point to where the sun is behind that solid blanket of cloud. That's the whole description. No explanation of what the stone looked like or how it worked or what it was made of. It's just presented as a fact, a tool a knowledgeable person would use. For centuries, that passage was read as a curiosity, maybe a poetic metaphor or a bit of magical folklore in the story. Scholars debated it. Was it a real object or just a literary device? That uncertainty kept the Sunstone in the realm of legend, but then something changed. In the 20th century, historians and scientists started looking at that old line not as a myth, but as a clue. A technical clue. They began asking a different question. If it was a real tool, what kind of crystal could do that? What property of light could it be using? That shifted the whole investigation. The Sunstone moved from medieval literature into modern physics labs. It became a puzzle to be solved with science, not just interpreted from text. That one obscure mention sparked a huge historical investigation. It connected the dots between the saga accounts of incredible voyages and the practical reality of how they might have been possible. The search wasn't for a metaphor anymore, it was for a lost piece of technology, a crystal that could see the invisible. The secret is in a property of light our eyes don't normally see. Sunlight comes to us as waves vibrating in all directions, but when it scatters in the atmosphere, something happens. That scattering organizes the light. It filters it so the waves start vibrating mostly in one plane. That's polarized light. It's physics, not magic, and it creates this consistent, invisible pattern across the whole sky. You get a broad band of this organized light, forming an arc 90 degrees from the sun. Even on a completely overcast day, that pattern is still there. The clouds diffuse the light, but they don't erase that hidden signature. The sun's position is still written into the sky in this language of polarization. You can see a bit of this yourself with a common pair of polarized sunglasses. Tilt your head while looking at a blue sky, and you might notice patches of the sky darken. That's the filter in the lenses blocking that specific organized light. It reveals the polarization pattern that's always there. For a Viking navigator staring into a featureless gray void, this wasn't just an optical effect. It was a potential map. That consistent band of polarized light running perpendicular to the sun could act as a guideline. If you could find that band, you could figure out where the sun was hiding. The challenge is human eyes are terrible at directly seeing this polarization. We need a key to unlock that hidden information. The overcast sky wasn't a blank page to them. It was a coded message, and the science of skylight polarization suggests they had the decoder. The hidden language of polarized light needed a translator. Something physical, so modern researchers looked for a real mineral that could do that. The search came down to a few crystals, each with its own optical properties that matched the old description. The strongest candidate is a crystal called Iceland Spar. It's a perfectly clear form of calcite, and it has this powerful optical trick at double refraction. You look through a clear piece at a single dot, and you see two dots. The crystal splits the incoming light into two separate rays. That's the key to its potential use. If the light entering is already polarized, something happens. As you slowly rotate the stone, one of those two images starts to fade. It gets dimmer. And at a specific orientation, that duplicate image vanishes completely. At that exact moment, the crystal is aligned with the polarization pattern in the sky. A navigator could hold the stone up, rotate it until one image disappeared, and then know the alignment of that hidden band of light. From that alignment, he could figure out the sun's position, even if it was completely hidden. It's a precise, repeatable physical test. The process turns an invisible pattern into a visible change, but Iceland Spar wasn't the only possibility. Other minerals show a different property called dichroism. crystals like cordierite or tourmaline don't create double images. Instead, they change color based on how they're oriented to polarized light. A piece of cordierite might look blue one way and a pale yellow when rotated 90 degrees. A navigator could use that color shift as a guide, turning the stone until it showed a specific hue and find the alignment that way. Each crystal offers a different method to solve the same problem. So which one did the Vikings actually use? The historical and archaeological record gives some hints. Iceland's Spar is geologically plausible. It's found in Scandinavia. More importantly, a piece was discovered on an Elizabethan shipwreck from the 1500s, the Alderney ship. It was found near navigation instruments, which suggests it had a navigational purpose centuries after the Viking Age. That doesn't prove Viking use, but it shows the knowledge persisted. Cordierite, sometimes called Viking's compass, is also found in Norway and Sweden. It's a less dramatic crystal, but its color-changing property works and doesn't need precise carving. The truth is, we may never know the exact mineral for certain. Different navigators in different regions might have used different stones, whatever was locally available and worked for them. What matters is the principle. The Sunstone wasn't a single mythical object. It was a category of technology, a natural crystal understood and used to reveal a secret of the sky. That connection between abstract physics and a tangible, hold in your hand tool, that's what turns the Sagas' one-line wonder into a believable, brilliant feat of ancient innovation. So you have the right crystal, then it becomes a physical ritual, a quiet act of observation. A navigator would stand on the deck, maybe find a moment of stillness. He'd take the Sunstone, a piece of Iceland spar about the size of a thumb, and hold it up toward the sky where he thought the sun might be. He wouldn't look at the sun. He'd look through the stone. His gaze would fall on a distant cloud or just into the gray, and then he'd rotate the crystal, slowly, carefully. If it was Iceland spar, he'd watch for two faint images inside the stone, two ghostly dots of light. As he turns it, those two dots change. One grows dimmer, the other brighter. He keeps rotating until one of those images vanishes, fading into the background. At that precise angle, the crystal is aligned with the hidden polarization band in the sky. He marks that orientation, maybe by noting a scratch on the stone's edge against a fixed point on the ship. That alignment gives him a line, a 90-degree arc from which he can deduce the sun's position. If he used a dichroic stone like cordierite, the process would be similar, but the cue would be color. He'd rotate the stone, watching its hue shift from a deep blue to a pale, almost transparent yellow. The point of most intense color, or the moment it shifts, again reveals the alignment. It sounds straightforward when described, but in practice it demanded immense skill. The changes are subtle. The light on an overcast day is already weak. The rocking of the ship, the strain in your eyes from staring into the gloom, the need for speed before the weather shifts again, all of that complicated the simple act of turning a stone. This wasn't a push-button instrument. It was an extension of the navigator's own senses, calibrated by experience. He had to know what he was looking for. He had to trust the faint signal from the crystal over the overwhelming evidence of his own eyes that told him there was nothing to see. This practical method transforms the Sunstone from a theoretical idea into a believable tool. It bridges the gap between a line in a saga and the cold, wet reality of the North Atlantic. It shows us the Vikings weren't just lucky or blindly courageous. They were engineers of perception, using the laws of nature as they understood them to carve a path across an invisible sea. The theory was beautiful, but modern science needed proof. So researchers tested it. In 2011, a team took a piece of clear calcite, Iceland spar, and went outside under a twilight sky. The sun was just below the horizon. They used the stone to estimate its hidden position, rotating the crystal until the double image became one. The results were staggering. Their measurements located the sun with over 99% accuracy. That experiment changed the Sunstone from a plausible idea into a validated tool. It proved the principle worked with incredible precision under a real sky. The research continued. Later studies used computer simulations to model the technique across the North Atlantic. They factored in the changing sun angle with the seasons, the different latitudes, the thick, uniform cloud cover of that region. The simulations showed that even with these variables, a skilled navigator using a sunstone could hold a course within a very narrow margin of error. It wasn't a tool for pinpoint landfall. It was for holding a steady east-west line across the ocean, which is exactly what a voyage from Norway to Greenland required. The most compelling tests came from the sea itself. Modern sailors with replica crystals have undertaken voyages using only these ancient methods. They faced the same gray skies and rolling swells. The reports from these trials are telling. The method is challenging, it requires practice, but it consistently provided a reliable reference point when every other visual cue was gone. It offered a fixed bearing in a fluid world, a way to break the symmetry of an overcast sky. These experiments from the lab to the open ocean build a powerful case. They show the Sunstone wasn't just theoretically possible, it was practically brilliant. Yet for all this evidence, a crucial piece is missing from the archaeological record. No sunstone has ever been conclusively found with a Viking ship or settlement. We have that piece from the Elizabethan wreck. We have crystals from Norse sites, but none directly alongside a navigator's other tools. This absence is the historian's necessary caution. It means we must say the method is strongly supported, entirely feasible, but not definitively proven. This gap doesn't weaken the story, it deepens the mystery. It reminds us that the most sophisticated technologies of the past were often made from perishable things. Wood, cord, and in this case, a crystal that could be lost or simply returned to the earth. The scientific validation gives rigorous credibility to the whispers of history. It lets us look at those old saga lines not as fantasy, but as a likely record of a lost form of sight. It was never just one method. The Sunstone's real power came from being part of a system. A whole network of techniques with checks and balances. It was like a safety net, a specialized tool you'd only pull out when the main methods failed. On a clear day, a navigator wouldn't need the crystal. He could use a sun compass, a simple wooden disc with a central pin that cast a shadow. By tracking that shadow's movement, he could hold a steady east-west line. And he could do it with real accuracy, but that tool was useless once the clouds came in. That's where the Sunstone fit. A navigator looking at a solid gray sky would use the crystal to locate the hidden sun. To get that bearing, that azimuth, once he had it, he could translate it. He could set that bearing against his mental map of the course, or he could use it to orient a physical sun shadow board. A carved board that simulated the sun's path, and then he could sail by that for the rest of the day. The stone gave the missing date a point. It made the other tools work again. But this integration demanded deep knowledge, memorized knowledge. A navigator had to carry a mental almanac of the sun's behavior. He needed to know its declination, how high it climbed in the sky at different times of year. In midsummer near the Arctic Circle, the sun might just skim the horizon. It never really set. In deep winter, daylight was a brief, low arc. The Sunstone could tell him where the sun was along the horizon. But to understand what that meant for his latitude, for his journey, he had to know the season's solar script by heart. So you had this combination, real-time data from the crystal, applied through memorized solar tables and physical tools that created a robust protocol. It was redundancy built for survival. If birds were absent, he read the swells. If the swells were confused, he watched the stars. And if the stars and the sun were both veiled for days, he had the stone. Any single layer could fail, but it was unlikely they would all fail at once. That changes the understanding. It wasn't a single brilliant hack. It was a sustained intellectual tradition. The Viking navigator wasn't just a sailor with a lucky rock. He was a practitioner of environmental science, a human processor synthesizing data from the sea, the sky, animal behavior, and the subtle signals trapped inside a crystal. The Sunstone was the keystone, the piece that held the arch together during the worst conditions. It meant a week of overcast weather wasn't inevitable doom. It was just a switch to a different, more subtle mode of wayfinding. This system allowed for continuous correction. It turned a desperate gamble across the Atlantic into a repeatable feat. Almost a routine, so we can marvel at the crystal, but we should save equal awe for the mind that knew how to use it and the culture that wove it into a complete art. The art of finding the way. The Viking Sunstone is a ghost in the archaeology. We have the theory, the science, the saga references, but the physical proof, the actual artifact, just isn't there. No crystal found by a ship's steering oar or in a navigator's kit. That absence is the biggest problem. It makes you ask why. Why is the evidence so hard to find? You have to think about the tool itself. A sunstone, especially one made of clear calcite, is fragile. It can shatter. It could be lost overboard in a storm. And its function isn't obvious. To someone who doesn't know, a piece of Iceland spar is just a clear rock, a pretty stone. It doesn't announce itself as a navigational instrument. It could be decoration, a trade item, raw material. That ambiguity makes identifying a potential sunstone very difficult. There are clues, though. The most famous is from the Alderney shipwreck, an English ship that sank in the late 1500s. Among its navigation tools, they found a clear calcite crystal. Its location, its context, strongly suggest a navigational purpose. It shows that knowledge of using such crystals persisted long after the Vikings. It's powerful circumstantial evidence, but it's not Viking. From the Viking era, the finds are more subtle. Crystals have been found, calcite, cordierite, discovered in graves in settlement sites across Scandinavia, some in wealthy burials placed with other personal items. Scholars debate what they mean. Were they amulets, status symbols, or could they have been the prized tools of a skilled navigator buried with him? The interpretation is open. A crystal in a grave doesn't prove it was a sunstone, but it doesn't rule it out either. It sits in that space of possibility. Archaeology only preserves a fraction of the past. Usually the most durable fraction. We find swords, brooches, ships, longhouses. The perishable stuff, the wood, the cloth, the knowledge, it often vanishes. And perhaps the delicate crystals too. The sunstone may have been a victim of its own practicality. A small, vital tool used daily and kept close. That makes it more likely to be lost to the sea than carefully buried for us to find centuries later. That gap creates a separation between what's compelling and what's conclusive. The circumstantial case is remarkably strong. The scientific validation, the historical mentions, the logical fit within Viking navigation. It all points toward the sunstone's reality. But without that one definitive find, we have to speak in terms of high probability, not absolute certainty. And that's not a weakness of the theory, it's a reminder of the fragmentary nature of history itself. Our understanding is built piece by piece. And sometimes the most brilliant pieces are the ones that leave the faintest trace. The search continues. Every new excavation holds that potential to turn a compelling what-if into a concrete here it is. The night sky wasn't empty. It was a map of fixed lights, so when the sun went down, the Viking navigator would look up and he'd find his constants. His main guide was Polarized, the North Star. It's the one star that doesn't move. It just sits there, marking true north for them, sailing the northern seas. That was a gift. It was this fixed point. The whole sky turned around it, but they knew more than just that one star. They knew the constellations, the patterns. They knew which ones marked the seasons, which ones marked the hours. The old stories mentioned specific stars, specific paths. This was a studied thing. They understood, for example, that a star's height above the horizon told you how far north or south you were. That's the idea behind latitude sailing. Say you're sailing from Norway to a settlement in Greenland. You know that settlement is at a certain latitude. So you don't need a complicated course. You sail west, but you're always checking your north-south position. You do that by watching Polaris. You measure its angle above the horizon. If that angle gets smaller, you're drifting south. If it gets bigger, you're going too far north. Your job is to keep that star at one fixed height for the whole trip. You're sailing along a line of latitude. It's a line in the sky. Now, think about the Sunstone. During the day, it could find the hidden sun and give you an east-west line. At night, the stars, especially Polaris, gave you a north-south line. So together, you had a complete grid, a full coordinate system. The Sunstone was the horizontal axis. The stars were the vertical axis. That integration is what made it work. It made it precise over such long distances. It shows a real sophistication. They weren't just guessing. They were reading the geometry of the heavens. They saw the Earth inside a cosmic sphere, and they used the consistent motion of that sphere to cross an empty ocean. They read the whole sky, day and night, clear or cloudy. The Sunstone unlocked the day. The stars were the map for the night, and in the navigator's mind, those two pieces of knowledge were woven together. It was one unbroken art. The Sunstone theory has its critics, of course. Some historians are more cautious. They point out that the only reference, the one in the tale of Hrothulf, is a literary text. It was written down centuries after the fact, so the Sunstone could be a later embellishment, a poetic device to show King Olaf's wisdom, not a report of a real tool. That's a valid point, and the fact that we've never found such a crystal gives that skepticism weight. Maybe we're over-interpreting a metaphor, applying modern science to an ancient storyteller's flourish. From this view, Viking navigation was brilliant but entirely terrestrial, observational. It relied on accumulated knowledge passed down. The navigator's real toolkit was his memory. The flight paths of certain seabirds like fulmars or gannets returning to land at dusk, the patterns of ocean swells bending around distant islands, creating a specific rhythm against the hull. The color of the water, the smell, the seaweed, the behavior of whales, these were the consistent signs. With that kind of environmental literacy, a crystal might have been unnecessary. The sea itself provided the answers if you knew how to listen. Then there are other theories for how they crossed such distances. One is sheer accident. The North Atlantic is a storm factory. A vessel could have been blown wildly off course, surviving a week-long gale, only to make landfall somewhere new entirely by chance. It's possible the sagas speak of ships lost to weather. If a crew survived and returned with tales of new land that would spark deliberate follow-up voyages. Chance discovery, then intentional exploration. Another idea focuses on following natural highways. Whale migrations create predictable routes. Seabirds fly straight lines between feeding grounds and nesting colonies. A navigator watching these patterns might infer the existence of distant coastlines. Sailing migratory routes could have been a strategic choice, using biology as a guide. Engaging these counterarguments doesn't weaken the Sunstone story, it enriches it. It shows that history is rarely a solved equation. It's a conversation, often a debate, where evidence is weighed and interpretations clash. The Sunstone hypothesis gains credibility not by ignoring other possibilities, but by standing up to them. The scientific experiments answer the chance argument by showing a repeatable method. And fitting the crystal into a broader system addresses the critique that traditional methods were sufficient. It suggests they were supplemented, not replaced. What emerges is a more nuanced picture, more human. It likely wasn't one single thing, not just a crystal, not just birds, not just a storm. It was all of these interacting. A navigator used every piece of data he could get. On a perfect day, he used the sun. When it was cloudy, he might have reached for a stone. When the stars were out, he used them. He watched for birds, he felt the waves, and yes, sometimes he just endured a storm and found something new. The Sunstone, if it existed, fits into this mosaic not as a magical answer, but as a sophisticated tool for specific conditions. Acknowledging the full spectrum of possibilities doesn't close the mystery. It opens it wider. It lets us appreciate the adaptability, the resourcefulness required to explore a world that was still mostly blank space on the map. This knowledge wasn't written down, it was in the voices of teachers, in the memories of apprentices. Viking navigation was an oral tradition, a craft passed from person to person through experience. The precise technique for using a sunstone, the subtle feel of rotating the crystal until the image faded, that was guarded wisdom, taught on the deck of a ship. A master navigator would show his student how to hold the stone, what to look for in the shifting light, how to interpret that faint signal against the rocking of the waves. This was knowledge refined over a lifetime, a personal skill like a signature, learned by doing, by failing, by trying again. This method of transmission explains a lot. It tells us why there are no Viking navigation textbooks. The secrets were in songs, in rhythmic sailing directions recited like poetry, in the careful observation of a mentor. The student didn't just memorize facts, he absorbed a way of seeing. He learned to read the sea's mood, the sky's hidden patterns, the quiet message of a crystal. All as one interconnected language, and this is also why the skill could vanish. When the Viking age faded and new tools like the magnetic compass arrived, the old ways became less necessary. The master-apprentice chains broke, the songs weren't sung anymore. That specific hands-on technique for the Sunstone dependent on that direct personal teaching. It just faded from memory. It became a ghost in the sagas, a single puzzling line waiting centuries for science to give it context, and that reveals something, a truth about technology itself. The most sophisticated tool is inert. Without the deep, experiential wisdom to wield it, it's just an object. The Sunstone was just a rock. Its power came from the mind trained to ask it the right question. And from the culture that sustained that training across generations. It was the fusion, the object and the understanding. That's what let them see the invisible and sail into the unknown. The voyage began at the western settlement in Greenland, a few farms at the very edge of everything they knew. From there, the course was southwest. The first real test was the Davis Strait, the Labrador Sea. That's a world of ice. Even in summer, bergs break off the glaciers and float south on the cold water. The sea is that deep, chilling blue, and where it meets warmer air, the fog forms. You could lose sight of everything for days. That's where the Sunstone changed. It went from being helpful to being essential. On a clear day, you could follow the sun, you could see landmarks, but when everything turned the same flat gray, and you knew the ice was out there somewhere in the mist, keeping a straight line was what kept you alive. The navigator would use the crystal again and again, maybe every hour, just to confirm that southwest heading. He wasn't looking for land yet. He was holding that invisible line across open water, trusting what the stone showed him over the sameness all around the ship. After days of that, a new coast would appear in the haze, not green, stark and towering, flat stone slabs and mountains with no trees. That was Helluland. What we call Baffin Island, the sagas describe it exactly. It was a sign they were on the right path, but it wasn't the place they were trying to reach. The next part of the journey was south, following the Labrador coast. That brought a different kind of problem. Now he was in coastal waters. There were landmarks, headlands, bird colonies, the way the shoreline changed. But the fog there is famous. It rolls in without any warning and covers the whole coast. If he got caught in a thick bank with a rocky shore somewhere off to the east, he needed to know where he was relative to the open ocean. A fast check with the Sunstone could give him the sun's bearing. That would tell him if he was sailing along the coast or if he was being pushed dangerously toward it. It was a way to avoid getting trapped. As they kept going south, the land changed. The stone barrens faded into deep, endless forest, Markland, the land of wood. Modern Labrador, for Greenlanders on a treeless island, that shore was a treasure. But those dense woods came right down to the water. For miles, the coastline looked the same. And again, the fog was a constant threat. Sailing that coast took patience, constant small corrections. The Sunstone was the anchor, the fixed point that kept them from drifting in the murk or missing the turn they needed to make. Finally, the voyage ended. They sailed past the Great Strait of Belle Isle, rounded the northern tip of Newfoundland, and worked down the western coast. In a sheltered bay, they built their small settlement, Elance Aux Meadows. That was Vineland. Getting to that specific spot required precision. They weren't just arriving on a continent. They were navigating to one particular harbor. That last approach, often in autumn when the seas were rough and the weather was unpredictable, would have asked the most of all their skills. The Sunstone, along with watching the stars at night, reading the water depth, watching the birds, it all guided them to a safe place to land. You can see it not as using a magic crystal the whole way, but using a key tool at the most critical, disorienting moments. It turned a dangerous journey through ice and fog and unknown currents into a route they could follow again, a path from the edge of their world to the doorstep of a new one. The crystal gave a bearing, but the sea itself gave directions. A Viking navigator's real skill was reading the environment. It was a constant dialogue with the natural world. He'd watch the water's color change, from the deep indigo of open ocean to a milky green near the coast. That was a visual clue. Land was nearing long before you saw it on the horizon. He learned the language of clouds, certain formations, a stationary, dark bank on a clear skyline that could signal an island or a mountain range dozens of miles away. Their presence changed the weather patterns overhead. Even driftwood carried messages, finding timber with unfamiliar bark floating on the current. That wasn't just debris. It was a promise. It meant a forested shore was upwind, a source of resources, or just confirmation they were on the right track. But the most reliable guides were the birds. Species like the fulmar and the puffin, they became living compasses. These birds have fixed behaviors. At the end of a day's feeding far out at sea, they fly straight back to their cliffside nests. A navigator watching a fulmar's swift, direct flight at dusk could follow it home, follow it to land. This was so systematic it became a documented strategy. The landfall bird technique. If the sky was featureless, if the seas offered no clues, a crew might release a raven they carried aboard. If the bird circled the ship aimlessly, it saw no land. It would return, but if it flew off decisively in one direction, the helmsman would steer that course, trusting the bird's instinct over human guesswork. This wasn't superstition, it was biological pragmatism. They were outsourcing reconnaissance to a creature with a far greater sensory range. This ecological literacy framed everything. The Sunstone wasn't a replacement for that deep knowledge. It was a specialized interpreter for one crucial, invisible data point. The system worked in layers. Birds could guide you to a coastline, but not tell you your longitudinal position. The Sunstone could give you an exact east-west bearing, but couldn't warn you of a hidden reef. One was broad awareness, the other was precise measurement. Together, they created a resilient form of wayfinding. The navigator was never relying on a single point of failure. He was conducting a continuous conversation, asking questions of the waves, the sky, the wildlife, and the light trapped in a crystal, synthesizing their answers into a course. His ship moved through a world that was constantly speaking. His skill was in knowing how to listen. The Sunstone didn't just disappear when the Viking ships stopped sailing. It faded into folklore. In later Scandinavian stories, the Solarstein changed. It wasn't a tool anymore. It became a magical thing. Tales described stones that could show you the sun at midnight, or predict the weather, or reveal someone's fate. That change from a navigation aid to an object of enchantment, it's significant. It shows what happens. A real piece of technology, once it's not understood anymore, it turns into legend. The knowledge of how to use it is gone, so the object stays in memory, but its purpose gets reimagined. It's seen through wonder, through mystery. You find mentions of these sun-finding stones in later texts from early modern writers. They're trying to understand the old sagas. They treat them as curiosities, relics from a half-mythical past. They were pieces of a puzzle nobody could solve, and that's where it stayed for centuries. Dormant then, in the 20th century, things shifted. The Sunstone was found again, not by digging it up, but by reading. Historians and scientists went back to those same old texts. They had a new perspective. The catalyst was a better grasp of skylight polarization. Mid-century researchers were studying insects, bees, and how they navigate using polarized light. And that led to a radical question. Could humans have done something similar? Once that scientific insight emerged, it provided the missing mechanism. It gave a physical, plausible explanation for those vague saga descriptions. Suddenly, the Sunstone wasn't just folklore. It was back in the realm of credible history. It's a clear case of a new scientific concept bringing an ancient idea back to life, giving us a new way to look at the past, and this rediscovery caught on with the public. The romantic idea was strong, a crystal that lets Vikings see the hidden sun. It supported a narrative about lost advanced knowledge. It hinted that ancient seafarers were more sophisticated than we'd given them credit for. So the Sunstone started showing up in novels, documentaries, video games. It turned into a symbol of Viking cleverness, a single, elegant answer to the huge question of how they managed those voyages. That popularization, even if it oversimplified a complex navigation system, it did something important. It created interest. It brought in funding for more research. It made people consider that intersection of nature, physics, and human ingenuity. The whole path of the Sunstone, from a practical tool to a forgotten legend to a scientifically supported theory, it points to a larger pattern. It's about our need to solve the puzzles our ancestors left behind. We're drawn to gaps in the historical record. They make us wonder. They make us investigate. They let us connect points across time. The Sunstone story is powerful not because it's a final answer, but because it exists right at that intersection. Where hard evidence meets a compelling theory, where archaeology meets physics, and where our respect for the past meets our desire to understand how they saw their world. The Vikings weren't the only ones who could read the sea. There was another culture far away in the Pacific, mastering a different kind of open ocean navigation. The Polynesians, their story runs parallel. Both peoples crossed thousands of miles of open ocean. Both did it with Stone Age technology, no magnetic compass, no sextant, none of the instruments from later European exploration. But their methods diverged. They came from different oceans, different skies. The Polynesian navigator memorized a mental star compass. He knew which stars rose and set over specific islands, and he used zenith stars. As he sailed north or south, different stars passed directly overhead. When Sirius was directly above him, he was at the latitude of Tahiti. When Arcturus was at his zenith, he was at the latitude of Hawaii. That was his celestial latitude system. The sky itself was the instrument. During the day, he turned to the ocean swells. He learned the dominant swell patterns, the deep waves from distant trade winds. He would lie in the hull of his canoe, feeling the rhythm through his body. A secondary swell, reflecting off an island dozens of miles away, would create a subtle interference. He could detect that. It was like hearing a faint echo in a consistent sound. They called it wave piloting. It let him sense land long before it was visible. And to hold a course by keeping a specific angle to those swells. They also watched for birds like the golden plover, the gathering of clouds, the color of the water. Now place the Viking system beside this. The Viking navigator also used stars, but his constant was Polaris, a fixed point in the north. He sailed latitudes by holding that star at a steady height. For daytime guidance, the potential use of the Sunstone, a crystal that could give a fixed solar bearing through cloud, that's a key contrast. The Polynesian system was deeply holistic. It integrated body, memory, a dynamic living seascape. The Viking system was also holistic, but it potentially incorporated a physical tool, a crystal to extract one specific, invisible data point from the sky. One method relied on an exquisite sensitivity to natural patterns. The other may have used a tool to reveal a hidden pattern within a pattern. Both are testaments to knowledge accumulated over generations. Both required a lifetime of training, and both were displaced by new technology, the magnetic compass, the chronometer, tools that made wayfinding more accessible, but perhaps less connected to the world. This comparison does something. It lifts the Sunstone from a Viking curiosity into a global narrative. The drive to explore sparked multiple brilliant solutions. In the Pacific, the solution was an unparalleled sensory and mnemonic art. In the North Atlantic, it was that same art, possibly augmented by a clever understanding of light. The Polynesian voyager felt his way across the ocean. The Viking navigator with his Sunstone might have seen his way through it. These aren't competing truths. They're complementary chapters in the same story, humanity's relentless, ingenious quest to find its place on the vast blue map of the world. Elance Orcs Meadows wasn't a permanent home. It was more of a gateway. You had a small cluster of buildings there with sod walls. They had forges for working iron, facilities for repairing boats. It was a base camp, a seasonal workshop. They'd process timber, gather resources, probably explored further south from there, but the settlement only lasted a few years. Maybe a decade at most. The sagas talk about conflict with the people already living there, the indigenous nations. The Norse called them skraelings. That term, it likely means shriekers. Or just others. It shows a profound distance, a cultural distance. The encounters they describe are tense, starting with cautious trade, moving to open hostility. Those clashes and then the sheer strain of it, maintaining a colony thousands of miles from Greenland. It made the whole venture unsustainable. The dream of Vineland as a new Norse frontier, it faded. The voyages stopped. The knowledge of the route, it was preserved only in stories, told by firesides in Iceland and Greenland for generations. For the indigenous peoples of the region, this contact was brief. A strange, isolated episode, a memory of unusual visitors from the sea who came and then did not return. The impact wasn't demographic. It wasn't cultural in any lasting way. No Norse genes took root there, no language, no technology. In that sense, Vineland was a historical dead end, a path not taken, but its modern rediscovery that changed everything. For centuries, the sagas were considered just that, epic tales, maybe with a kernel of truth but not literal history. Then Elance Orcs Meadows was found in the 1960s. It turned legend into fact. It proved the Norse had the capability to cross the Atlantic to establish a foothold. It rewrote the timeline of human migration, of contact in the Americas. It placed Europeans on those shores centuries before Columbus. That shifted the narrative from a story of discovery to one of encounter, and a very early one. A very brief one, so the true impact of Vineland, it lies in our modern understanding. It forces us to confront the complexity of history, a monumental achievement. In navigation, in exploration, it didn't lead to empire, it didn't lead to lasting change. It remained a fragile outpost, then a memory, then a myth. And finally, through archaeology, a confirmed chapter, it stands as a testament to what was possible and a reminder of what never came to be. The Sunstone wasn't perfect. No tool is. Its accuracy changed. It depended on where the sun was and the light. When the sun was low, near the horizon at sunrise or sunset, the pattern in the sky gets weaker. The signal fades, and on a heavy overcast day, that flat gray sky, the polarization is still there, but it's softer, harder to read. That required more skill. It introduced doubt. Then you have the person using it. The navigator is tired, cold, his eyes are strained. The ship is rolling. To hold the stone steady, to turn it slowly, watching for that shift in the image or the color, that takes intense focus. A tremor in your hand, a moment of impatience, and you can misread it by several degrees. Over hundreds of miles, a small error at the start becomes a big drift off course. And the stone doesn't guide you continuously. It gives you a snapshot, one bearing at one moment. You take that reading, you set your course, and then you sail by dead reckoning. You estimate your speed and direction until the next check. That could be hours. In that time, currents push you sideways, the wind shifts. The helmsman, trying to hold a course by the feel of the waves, might curve the path without meaning to. So the journey isn't a straight line, it's a series of corrections. You zigzag back toward your route, guided by these periodic glimpses through the crystal. That doesn't make their achievement smaller, it grounds it. It shows the Vikings not as infallible, not with some magic technology, but as skilled practitioners working at the very edge. They were masters of probability, not perfection. They knew their tools had limits. They built a system with layers of checks to manage that risk. They accepted a margin of error. The alternative was to never sail. Their confidence came from knowing they could correct for drift, from recognizing the signs they were off course, from trusting they could find the way again. This honest look at the limitations makes it more credible, more human. It wasn't about flawless execution. It was about resilient adaptation, pushing a fragile wooden ship and a fragile crystal to their absolute limits across that formidable ocean, and succeeding often enough to change the world. The Vikings had a way of steering their ships without any landmarks to go by. That same problem, how to navigate when you can't see where you're going, is a big one for robots now. A drone loses its GPS signal. A submarine vehicle is down in the dark ocean with nothing to look at. The answer engineers are using is the same old one, polarized light. They're making these little digital eyes, polarization sensors, that work like the Sunstone. They read the sky's pattern. For a drone, that means a compass in the sky, a backup that doesn't need satellites. It's the same solution 1,000 years later. This whole area is called bio-inspired design. You look at how nature already solved it. Bees use polarized light to travel and find their way home. Ants do it, so researchers copy those biological systems to make navigation modules that are tough and don't need much power. The idea is to make machines that work where our usual tech gives out. Deep underwater, where there's no light and the magnetic field is all wrong. Or on another planet like Mars, where the thin sky creates a sharp polarization pattern. A rover there might carry a modern sunstone to orient itself in a dust storm when the sun is just a faint blur. That changes the sunstone. It's not just an artifact anymore. It's a living idea. Looking into the past isn't only about what was. It's finding principles that still work. The Viking navigator had a perception problem. He used the physics of light to extend his own sight. Now we're doing that for our machines. We're building AIs that need to perceive the world, and sometimes the oldest insights give you the cleanest path. The Sunstone went from a saga to a physics lab to a circuit board. It shows that our drive to explore a new continent, a new algorithm, often follows trails that were already there. You just see them in a new light. For the Norse, the sun wasn't just light. It was a goddess, Sol, driving her chariot across the sky, chased by a wolf. Their world was alive. Gods and giants and fate shaped everything. So a tool that could find the hidden sun, could that ever be just a tool? The Sunstone sat at this intersection. A practical crystal and an object of symbolic power, to hold it up to see through the clouds that might have felt less like physics, more like a sacred act. Tapping into the divine order, aligning human work with the path of Sol herself. In that culture, seers practiced magic sather to see hidden truths. The Sunstone's function resonates with that. It granted a sight beyond ordinary vision, a form of insight, access to knowledge otherwise reserved for the gods. So the Navigator wasn't just a technician. He was an intermediary, someone who could read the hidden signatures of the cosmos and translate that into a safe course for his people. His skill bordered on the mystical because the forces he worked with were divine. This cultural layer changes the understanding. It suggests that for the Vikings, navigation wasn't a purely mechanical task. It was a holistic practice. Woven into their spiritual and mythological view of the universe, to sail was to navigate a landscape of stories, as much as water and wind. In this light, the Sunstone becomes a key. Not just to longitude, to a worldview, a physical bridge between the human realm of the longship and the divine realm of the sky. It reminds us that innovation in the past was rarely separate from belief. Often, the drive to master the physical world was fueled by a desire to commune with the forces that governed it. So next time we picture that navigator on a foggy sea, we should see more than a sailor with a clever rock. We might see a figure in a silent dialogue with the gods, seeking permission and guidance to cross from the known world into the mystery of the new. The Viking Sunstone story is powerful, but it's wrapped in layers of myth. One of the most persistent is the idea of the Viking raven navigator. That image is iconic. A ship lost in the mist, a raven released from a cage, flying toward an unseen shore. But that's dramatic, and it confuses a single, legendary episode with standard practice. The story comes from the saga of Floki Vilhjalmsson, an early explorer of Iceland. He took ravens aboard to help find land. It was a clever, one-time strategy. It wasn't a standard, everyday navigation tool. Think of it as an experiment, not a protocol. Birds were part of their environmental awareness. Watching the flight paths of seabirds like fulmars, that was a routine, reliable method. But the raven story has been amplified. It's become the defining symbol of Viking wayfinding, and that overshadows the far more sophisticated system they actually used. A similar exaggeration surrounds the Sunstone itself. In some modern portrayals, it's shown as a kind of magical GPS, a crystal that glows or points an arrow, giving continuous, pinpoint directions. That's a fantasy. The historical and scientific theory is much more grounded, and in many ways more impressive. The crystal didn't point, it didn't glow. It gave a single, subtle data point, a bearing to the hidden sun, which a navigator then had to interpret, using his memorized knowledge of the sun's seasonal path. Its precision was high under good conditions, but it wasn't infallible. It had limitations, weather, the sun's altitude, human skill. It was a brilliant workaround for a specific problem, overcast skies. Not an all-seeing oracle, this distinction is crucial. It separates a compelling historical theory from science fiction. The plausible use of a crystal like Iceland Spar is supported by physics. It's been replicated in experiments. It fits logically within the Norse toolkit, the fanciful version where the stone has supernatural properties that belongs to legend. One is a testament to human ingenuity working within natural laws. The other is a projection of our own desire for simple, magical solutions. By clarifying this, we don't diminish the achievement. We honor it more honestly. We see the Vikings not as fantasy heroes with magical gadgets, but as real, resourceful people. People who solved immense practical challenges with the materials and understanding they had. Their true story doesn't need embellishment. The reality of sailing a wooden ship across the North Atlantic using the hidden patterns of light, that's astonishing enough. It asks us to appreciate the depth of their knowledge, not the simplicity of a myth. Even the most brilliant knowledge can be forgotten. The Sunstone technique, if it was truly used, never spread beyond the Norse world. It didn't become standard for European navigation. Its disappearance is a story of changing worlds. The Norse settlements in Greenland and Iceland, those gateways to the west, they began to fade after the 14th century. Life there became harder, the climate was shifting, the Little Ice Age was setting in, summers grew shorter, winters longer, more severe, the sea ice advanced. The old sailing routes to Vineland and Markland became choked with danger, more isolated with each generation. The communities that sustained these voyages were themselves struggling. The specialized knowledge of the Sunstone was tied to a specific way of life, a specific set of challenges on the North Atlantic. When that way of life contracted, the need for that tool contracted with it. It became a memory, then a whisper. At the same time, a new technology was spreading north from the Mediterranean world, the magnetic compass. By the 13th and 14th centuries, this instrument was revolutionizing navigation for southern European sailors. It worked in any weather, day or night. It didn't require interpreting subtle shifts of light through a crystal. It pointed north reliably and clearly. For the Norse, adopting the compass would have meant abandoning a deep, experiential art for a simpler tool. When your survival depends on crossing the sea, you take the surest method available. The compass, combined with improving charts and tables, represented a new, standardized system. A technology that could be taught quickly, replicated easily, used by sailors who hadn't spent a lifetime learning to read the waves or the sky's hidden patterns. The old oral tradition, with its master navigators and their guarded crystals, couldn't compete with that kind of practical efficiency. It was like moving from a handwritten, illuminated manuscript to a printed book. One was a work of art, deeply personal. The other was a tool for mass communication, so the Sunstone didn't fail. The world around it changed, the cultural and environmental niche that had created it and sustained it simply closed. The settlements that held the knowledge grew quiet. The master-apprentice chains broke. The last navigator who knew the precise feel of the crystal in his hand, the exact look of the fading double image on a heavy gray day, he took that skill with him. What remained were the stories, the echoes in the sagas, a single, puzzling line about a king and a sunstone, waiting for a future age with different tools and different questions to see it not as magic, but as physics. This legacy of loss is a profound lesson. It shows that human knowledge isn't a steadily rising line. It's a fragile ecosystem. Specialized technologies, no matter how advanced, can vanish when the specific conditions that fostered them disappear. They leave behind only fragments for us to find, and a haunting question: what other brilliant ways of seeing the world have faded into silence, leaving only the faintest trace in an old tale? The Sunstone has traveled a long way from its historical origins. It lives a whole other life now in our stories. In novels, it's often this crucial artifact. A key to unlocking a character's destiny or finding some lost Viking settlement. Historical fiction authors weave it into their plots. They treat it with a kind of reverence, but also a lot of creative freedom. The crystal becomes a tangible link to the past, something a character can actually hold, a symbol of that navigator's almost supernatural skill. That approach respects the mystery, but also gives it real narrative weight. In fantasy, the transformation is more dramatic. There, the Sunstone might glow with its own light, or hum with some kind of power. It could be a compass that doesn't just point to the sun, but to hidden treasures or magical gateways. It's fully enchanted, a piece of world building that borrows the allure of the historical idea, but leaves the actual physics completely behind. These portrayals aren't about accuracy. They're about wonder, and in doing that, they introduce the whole concept to people who might never read a scientific paper on skylight polarization. Film and television have amplified this visual myth. On screen, the Sunstone is usually bigger, more polished, more obviously mystical than any practical tool would be. A navigator holds it up and a beam of light might pierce the clouds, dramatically showing the way forward. Those are powerful cinematic moments. They trade subtlety for spectacle, making the invisible visible in the most literal way for the viewer. It's a visual shorthand. It communicates seeing the unseen, but it sacrifices the quiet, meticulous reality of the historical method. Video games take it a step further, especially historical or fantasy action games. The Sunstone becomes a gameplay mechanic, an item in your inventory that, when you use it, clears the fog on your map or reveals hidden paths. It's functionalized, turning ancient wayfinding into a button press. That interactivity lets the player feel the power of the tool directly. Even if that power is grossly simplified, the cumulative effect of all this is a powerful reshaping of public perception. For a lot of people, their first and only encounter with the Sunstone is through these fictional lenses. So the dominant image becomes one of magic and mystery, not calcite and polarized light. The scientific basis, the careful experiments, the nuanced debates among historians, all that recedes into the background. The Sunstone becomes a legend first, and a historical hypothesis a distant second that creates a tension. On one hand, these stories keep the idea alive. They make sure the word Sunstone has cultural currency. They spark a curiosity that can lead to deeper exploration. On the other hand, they can set expectations that reality struggles to meet. The truth is quieter, more fragile, and in many ways more intellectually demanding, which leads to a question of responsibility for creators. When you're blending historical mystery with narrative invention, where does the line lie? There's no single answer. Pure historical fiction might try to present the tool as plausibly as possible, grounding its use in the known challenges of the era. Fantasy has the freedom to reinvent it completely. The responsibility, maybe, is one of transparency, not necessarily in the story itself, but in the surrounding conversation. Acknowledging the leap from history to legend, recognizing that the fictional version is a tribute, an adaptation, not a documentary. The best stories inspired by history often send audiences searching for the real thing. They use the allure of the myth to open the door to the complexity of the past. This whole cultural analysis shows something fundamental about how we use history. We mine it for stories, a fragment like the Sunstone, a single line in a saga. An unexplained capability is a perfect narrative seed. It has a gap, a how did they do that begs for an explanation. And storytellers rush to fill that gap, not with peer-reviewed research, but with human drama, with magic, with adventure. In doing so, they ensure the legend lives on. Even if the historical truth becomes slightly harder to see, the Sunstone's journey from a possible navigational aid to a staple of fantasy lore shows that some ideas are too compelling to be left in the past. They capture our imagination precisely because they live in that beautiful, ambiguous space between what we know for certain and what we can only wonder about. That navigator on the deck with his crystal, he was part of something much larger. It's a principle, really, one that echoes the spirit of exploration, sure, but it's a specific kind. It's the ingenuity that looks at a blank sky and refuses to call it empty, that sees a problem you can't see the sun, and then looks for the solution. In the world in plain sight, the Sunstone wasn't invented, it was discovered. Someone noticed a property of a crystal. They connected it to a pattern in the sky. A pattern they could sense but not see, and they realized its potential. That's human ingenuity at the most fundamental level. Observation meeting need. Creativity meeting limitation. And this principle, it isn't just the Viking Age, it isn't just navigation, it's every breakthrough that comes from constraint. When you lack the obvious tool, you learn to read the world more deeply. You find signposts in the stars, in birds, in the shift of light through a piece of rock. The drive to explore, to go past the horizon, it forces this. It demands you become a detective of your environment, piecing together clues to make a map where there isn't one. The Viking navigator, the Polynesian wayfinder, the early astronaut, they share this trait. They are masters of making the invisible visible, using whatever is at hand to light the path forward. So for us today, we have digital maps, satellite guidance, but the principle hasn't vanished, it's transformed. Our uncharted territories aren't oceans of water. They're oceans of data, new scientific frontiers, personal challenges, societal challenges with no clear manual. Our sunstones are the tools we develop. The mindsets, they could be algorithms that model climate change, collaborative networks for global health, the personal resilience we build for uncertainty. The modern act of holding up that crystal is asking a new kind of question, seeking a hidden pattern in the noise, being willing to trust a subtle signal when the obvious landmarks are gone. The legacy of the Sunstone, then, it's not just about how Vikings might have reached America. It's a testament to a human capacity, a timeless one, the capacity to look at a barrier, a clouded sky, a vast sea, an unsolved equation, and not see a stop sign. But a puzzle, and within that puzzle to find the key the world itself has provided. It reminds us, exploration is a state of mind as much as a physical journey. It begins with a question whispered into the wind and is answered by learning to listen with all our ingenuity for the echo that shows the way. History is still being written. We haven't closed the book on the Viking Sunstone. The best finds might still be out there, waiting in the ground or on the ocean floor. Think about the definitive discovery. Archaeologists working on a preserved longship, maybe in clay, they find a small leather pouch near where the steering oar was. Inside, a clear piece of Iceland spar, its surface is worn smooth from use. And next to it, a simple wooden dial notched for a specific latitude. That one kit, a navigator's personal gear, would change everything. It would turn the Sunstone from a theory into a fact, a tool as real as the ship itself. That's not just a fantasy. Archaeological science is giving us new ways to see. Residue analysis can find microscopic traces, maybe the oils from a navigator's hand left on a crystal. Geochemical sourcing can trace a piece of calcite back to its exact quarry. So if a crystal from a Greenland settlement matched a mine in Norway, that tells a story. A story about trade and value and choosing something for a specific job. We can look at old museum artifacts again. A crystal labeled as decoration might show where patterns from being held and turned over and over. Then there's the sea, the North Atlantic. Underwater archaeology is finding ships that sank. Those sites are time capsules. A Viking Age wreck preserved in silt could hold all the personal items that rot on land. The Alderney crystal showed how that works. Finding something like that in a longship wreck with other sailing gear would be like watching a navigator work. Every new survey, every dive has that potential. This perspective matters. It means history isn't just answers in a book, it's an ongoing search. The story can change with one trowel stroke or one sound from a sonar. The Sunstone mystery is still open. Viking navigation is still open. The next big find might not even be a crystal. It could be a piece of wood with carvings that turn out to be a guide. Or a line in an old manuscript that finally explains it. The search itself means something. It shows we're still curious, we're still following their course, using the faintest clues across that vast sea of the past. We have this beautiful puzzle, a single line from an old saga, the physics of how light scatters in the atmosphere, a crystal that can split an image. And then an empty space in the archaeological record where that tool should be. Each thread on its own is just a curiosity, a historical mention, a natural phenomenon. A property of a mineral, an absence, but when you weave them together, something happens. They form a coherent picture, a picture of how it might have been done. The Sunstone hypothesis isn't about magic, it's about following a logical trail, from a problem to a potential solution, using what they had, what they knew. The Vikings had a navigational crisis under overcast skies. Science tells us the information they needed was still there in the sky, encoded in polarized light. Geology provides the crystals which they knew, crystals capable of reading that signal. Modern experiments show the method works, and with stunning accuracy. And the sagas hold this faint, cryptic memory of the tool itself. That convergence is powerful. It turns a collection of separate facts into a story of human ingenuity. It shows a culture capable of brilliant, empirical observation. They didn't just endure the North Atlantic, they learned to read its most hidden language. The lack of a definitive artifact is a real gap. It means we can't say for certain, but history is often about building the most plausible picture from incomplete evidence. And here, the picture is elegant, it fits, it solves the practical problem their voyages posed. It honors their reputation as master mariners, not with myth, but with a credible technique. A sophisticated one, this story is a triumph of thinking across disciplines. It required historians to read the texts as clues, not fantasy. It required physicists to model that ancient sky. It required archaeologists to interpret subtle finds, and it required modern sailors to feel the method on the open water. Each field, asking its own questions, added a piece. What emerges isn't a final verdict, it's a profound possibility, a respectful one. It lets us look at those weathered saga lines and at the cold, formidable expanse of the North Atlantic and see not just an adventure tale, but a likely record of lost science, a science of light and perception that guided wooden ships to a new world. The Viking Sunstone story is really a story about stories. It's an old book, a law of physics, and this human need to know the way. We started in the grey North Atlantic, then moved into modern labs, and out of that came a simple, elegant principle. A natural crystal, understood, could have carved a path across an ocean. It could have entered history, the final proof that one crystal in a navigator's hand might still be buried. Might be in the sea, but the evidence converges. It paints a picture that's hard to ignore. It changes how we see the Vikings, not just raiders, they were wayfinders. They were explorers. This tool asks us to look at old artifacts differently, not as primitive curiosities. They're fragments of lost science, innovation born from necessity. It asks us to listen to the old tales. Their whispers might describe a forgotten way of seeing the world.